Hi friends, in last lectures we have discussed about BFS. Okay, now we are going to discuss about the BFS traversals. Okay, let's see what is the BFS traversals. Okay, let's say we are going to discuss about BFS traversal. First, we should see what is the definition of the BFS traversals. Okay, so let's see. Okay, wait. Here you can see in the documentations what is the BFS traversal. BFS traversals is the fundamental graph traversal algorithm that explore all the neighbors at the present depth level. Okay, before moving to the node at the next depth levels. In this BFS traversals, we are exploring all the neighbors at the present depth. Okay, and after that we are moving to the next depth. Got it? Okay, what is the implementation, how BFS works? What is the implementations of BFS traversals? BFS follows the queue based approach. And what is that approach? In queue based approach, first start from a source node and mark it as a visited. Got it? And add the source node to the queue. Got it? And while the queue is not empty, we dequeue a node and process it. In queue all the unvisited nodes and repeat until all the reachable nodes. Let's understand these all steps by examples. Okay, this is our examples. Okay, here 0 is the root nodes. Got it? These are the root nodes, and these 1 and 2 are the parent nodes of these. Okay, and the third, these are the next levels. Here first level is one, this, second level is this, and the third level is this. Okay, so in BFS traversals we go for first levels. Okay, and mark it as a visitors. After that we will go for the second levels and traverse all nodes in second levels and mark it as a visitors. After that we will go for the third levels. Got it? This is a BFS traversals. So how we will implement this? To implement this, we are using the queue data structures. Okay, we will use queue, and let's initialize this is queue, and this here will be in tab data. Got it? And its name is queue, and other we will take vectors that mark the nodes is visited or not. We will initialize this visited array. Got it? So in first steps we will insert these root into queue. Here I have initialized this. Okay, now go now pop these elements, pop queue. Why till then queue is not empty. So if we will first we will initialize, you will insert root into the queue and mark this as a visitors. After that we will go traversal whole queue. Okay, and go for the pop these elements and take here node is 0. Got it? And go for the all neighbor nodes of the 0. Okay, what is the neighbor nodes of the 0? And that's are unvisited. That's at 1 or 2. So you will insert these into the queue and mark that node as the visitors. Got it? After that we will again go for the front elements of the queue, because this is popped. Now one will be the front elements. So if you will pop, then this will, oh, sorry, now what is the front element? Front element is 1. So here node will be 1. Okay, and this will be popped. Now go for the neighbor elements of the 1. What is the neighbor elements? Neighbor element 0, 3 and 4, but 0 are visited, so no need to consider again. Now go for 3 and 4. 3, 4 are neighbor nodes of 1. These nodes and that 3 or 4 are also not visited, so just push 3 and 4 into the cube and mark it as a visited. Got it? Now go for the next front elements of the queue. Next front element of queue is 2, so pop q. Got it? Here what will be the node? Node will be here 2. Okay, now see who is the neighbor of the 2. Here 0, 5 and 6 are the neighbor of the 2, but 0 is already visited, so no need further need to iterate or take 0. Now 5 and 6 are the neighbor, other neighbor nodes, and that's are also not visited, so take 5 and 6 and insert that element into queue. Okay, now go for the queue, and these 3 are the front elements of the queue, so just pop these elements, and here what will be the elements? These elements is 3 currently 3 here. So now go for the these. What is the neighbor elements of 3? Is 1, but 1 is already visited, so no need to do further anything. Now pop, now take that's front element 4 and pop these elements. So 4 has the also no any neighbors, so no need to do anything else. Again after that we will take these 5, here 5, take 5s and pop from here. Now 5 have also no any remaining elements, that's are the remaining neighbor elements, so go further for next elements. Next front element is 6, so pop, and here node is 6. Got it? So in 6 also there is no neighbor elements that remains. So after that you can see queue has empty. So after that the loop will be break, and finally your answers will be this: 0, 1, 2, 3, 4, 5, 6 in this order. So your answer will be also in this order only. Then your answer will be finally return 0, 1, 2, 3, 4, 5, 6. And you can see in level order traversals also seems like a BFS, because in BFS we are go level by level. Here in first levels only one elements presents, that's are 0, so 0. In second levels you can see this is the 1, 2, so after 0 there are 1 or 2 in second levels. After completion second level, what is the in third levels? 3, 4, 5, 6. So 3, 4, 5, 6, these are the, that's why this is our breadth first traversals. Got it? Let's implement these things. Here you can see I have taken a similar graph. Okay, now we need to write the BFS traversals. So let's write the BFS traversals. functions. And what is the needed? Here the needed is how what is adjacency lists. Got it? What is the adjacency list? Here only these things have needed. And let's take what is the size of the vectors, size of the nodes, what how many nodes are present. Got it? Let's write these functions. This is the void types, BFS traversals, and let's just copy the adjacency lists from here. And also take v. Got it? Initially what we will do, first create the queue. Sorry, this will be in types. So initialize queue. In queue we will first insert the root nodes. Root node is 0, so we will just insert and traverse these queue until queue is not empty. Got it? Let's take the front element of queue. It's node q dot front. This is the front elements, and at same times we will pop that elements also. Okay, now here also we need to initialize one visitors array initially, and that size will be v, and initially all will be false. Got it? So if we have pushed that's 0, wait, first initialize the visitors, after that we will initialize the we will take q data structures and we will push, and after pushing the 0th node we will mark this node as a visitors, and this will mark as the true. Got it? Now go for the next and go for the all neighbor elements of these node, and we will iterate all neighbors by these for loops. And if we will check if these it are not visitors, if this will be false, in that case we will push that node into the queue. Got it? And also here you can just print the node to see what is the order of the traversals. Okay, let's come. I have completed these all codes. Let's check first. Here this is the number of the nodes. Here initialize the adjacency lists, and this is our graph. Got it? Here I have initialized, but inside also I have initialized the visitors. So here this is not used. No, let's see, this is the BFS traversals, not the DFS traversals. So let's just copy these things and mark this is comment, and here see BFS. This is the BFS traversals only. Got it? Here I have a initialize the BFS functions, and here we will implement whole BFS functions. Here pass the adjacency lists and number of the nodes. Here I have initialized the visitors functions, and we will initialize the queue. Initially we will push the root nodes. After that it will mark this as the visitors. After that we will go inside and iterate whole queue until queue is not empty. And this is the, we will take front elements of the queue and pop that elements. Got it? And we will print that nodes. After that go for the whole iterations of the neighbor elements. If this will be not visitors, then we will push that element into the queue. Let's just run these codes. Oh, sorry, again I have mistakes these codes. After pushing that element, we need to mark that elements as a visitors. Got it? Now we will run. Now you can see BFS traversal is 0 1 2 3 4 5 6, and we have already seen these things 0 1 2 3 4 5 6. Okay, I have done these all things. Let's see some other informations regarding the BFS traversals in documentations. Here, what is the applications of the BFS traversals? BFS traversal is widely used in these all things to find the shortest path in unweighted graphs, okay, and finding the connected components. To find the connected component also we are using the BFS traversals. Cycle detections in undirected graph. To find the cycle detections in undirected graph, you are using the BFS traversals. Solving the puzzles, network broadcasting, web scrolling, and some other AI game and AI search strategy. In all these things we are using the BFS traversals, and I have just seen the implementations of the BFS traversal in C++ codes. Okay, what is the next? Let's see what is the time complexity of these implementations. These implementations time complexity is O of V plus E. Here V is the number of the nodes and E is the number of the edges. Got it? And space complexity is O of the V. Maximum of the V space will be taken to implement these code. Got it? And let's see some other things. Just see here, I have just discussed the time complexity. Let's see what is the difference between the BFS and DFS traversals. Let's on the basis of the data structure. So what is the difference between the BFS and DFS? In DFS traversals we are using the stacks. Got it? And in the BFS traversals we are using the queue. And on second, traversals orders. In traversal order, in DFS explore depth, whole depth first. After that we will go for the next. And in the BFS traversal, explore breadth, explore same levels first. And in the space complexity, O of the V in worst case in the case of the DFS, and O of V are using in the BFS also if all the nodes are at the same level. Got it? Then they will take O of V time complexity. And the use case are similar in DFS traversal are using in solving the maze, cycle detection, and topological sort. And BFS traversal are using shortest path to find the shortest path. Got it? These are the main difference between the BFS and DFS traversals. Got it? I have done these things. Okay, thank you.